All right, next up, we're moving on to modeling a basic parapet building that might have like a storefront or something. And this is kind of like your typical mid-rise 3 to 4 story building. And it's always helpful, again, to have a top view and also an elevation view of the building. And that's going to help you piece together everything that you need to model in all dimensions. So I've already made a basic massing for it. And what I'm going to do first is to reduce this to maybe 48 feet. That's kind of like 4 stories. And we'll notice with this is that it's approximately divided down the middle, maybe offset by like 2 feet, 1 feet or something. One side is quite plain and the other side has all these windows. So we'll do that first. And again, we'll just make this square with our C-plane so it's easier to work with. First thing that we'll do is just mark that line. So if this is the midpoint, this is the midline. If we move it over by maybe just 1 foot, that begins to look like the proportion that we have over here. And let's just go from the left side to the right side. So starting off, first we see that we have this kind of like doorway that's recessed. So what we can do is take a box, and it looks like it's maybe 6 feet across. The depth might be around 4 feet. And in terms of the height, we can go for something like, looks like it reaches very close to the ceiling. So we can go for 10 feet. That looks all right. And in terms of its offset from this center line, can make it around 2 feet. Remove it from our massing. That looks all right. And from here, we also have this kind of sign. And what we can do is just take this edge, maybe scale it down like that. And let's extrude it up. Let's say 2 feet. Maybe 2 feet, 3 inches. Using the surface, we'll just offset it. Offset surface. Okay, just one side. And then maybe we'll bring it out by 3 inches, that's okay. And with these things, it's always worth it to kind of like type out the sign. So it's like Prezzo. Should have found a better image that shows the full sign. But what you might want to do is just type out the sign. Let's say this is your sign, and you'll actually want to explode the text. And if you group it, and then let's say you rotate it, you can have some signage that's on your building. And if you make 2D, you'll see that it shows up as well. So if you pick the right font and then you have the right size, just like explode it and then move it onto your building, then you'll have a nice piece of signage to go with it as well. So next up, the thing that we actually want to look at is the door over here. So it looks like it might be divided along the 2/3 point. So we'll just do this edge, divide it by 3. And what we'll do is just take this point all the way up. That looks all right. And on top of that, what we'll actually want to do is to take all of these edges as well. So we'll use dupe edge again. Take all of these edges. That's good. And then we'll also split it by this line that we created right here. Deselecting these. We'll just take this line right here for that side window. Oh, actually, it looks like we also have one more frame coming down maybe by 1 foot. And we'll just split that line with this new line that we created. And that's basically the kind of dimensioning of the doorway and the windows. So what we can do from here is, actually we'll just take this line, we'll take that line. What we'll do is actually offset it. And because our C-plane is sort of, you know, it's on the ground, we actually want to adjust our C-plane that way. So that's C-plane, and then you can map it to an object. So in this case, I'm selecting that surface, and now our C-plane is aligned to this object. What I can do is offset this kind of frame detail, say 1.5 inches on both sides. That's good. Let's group them for the time being. And from here, we'll also offset this, both sides. That's good. Okay, that's our kind of basic framing detail. And it seems like this piece is actually not continuous, but it doesn't matter for the time being. What we can do is loft them together, loft these together, and take our middle surfaces and simply extrude them outwards, let's say by 3 inches. Okay. And we'll actually split this using this frame and delete the top one because the top one's continuous. All right, and from here we kind of get our framing detail. And what we'll also see is that there's these kind of like handles that come out as well. Not sure if that's for one side or both sides. Seems like it might be both sides. So that's actually a very skinny door, but you can adjust this as well if you just want to, like, say, move this face over by like 1 foot, move your sign over perhaps. And this one, maybe you just like scale it. That looks all right. But we'll also bring our C-plane back to kind of the ground. And we'll just quickly draw out our door handle here. So maybe 3 inches like that. And we'll extrude it by 12 inches. So if this is our sort of handle, we might maybe have it out by 2 inches. And we'll want to have it up at around 36-inch position. And maybe we can mirror this across this frame. That looks okay. Again, a lot of these details don't necessarily have to be very accurate, but when you make 2D, they should look proper and representative of what's actually happening. And for the most part, this gets the idea across. So we're basically done with that portion. And in terms of these lines that come across, there is the possibility of, creating an actual indent and subtracting from your massing. But if you make 2D, then what you might get is perhaps a kind of like doubling of some lines. So let's say you subtracted something that's like very, very small. Something very small from your building. Let's move this out a bit. And we make 2D. What you'll see is that this line appears quite thick because, well, there's actually two of them. And in some cases, this might be the effect that you want, but what we can see from this building is that the lines are in fact quite thin, so we actually don't want to do that. And we'll also notice that the pace of these lines follows a clear rhythm. So the ground floor is a bit taller than the upper floors, but what we'll see is that this spacing is the same as this spacing, and so on. So we'll also want to respect that. So let's backtrack on that. We'll just create some details using some lines. And maybe what we want to estimate for this portion is that might be somewhere like 4 feet, perhaps. That looks okay. And maybe it moves up by 6 feet afterwards. So another 4 feet. And we'll just continue on with these by 10 feet and by 10 feet. And it seems like our initial massing might have been a bit taller than imagined. So what we can do is just like move down that face. You can also move face, move this face and snap it down like so. Okay, so those are our kind of lines. We'll move this down as well. And then after that, we'll focus on the windows. So maybe the first thing that I actually want to do is recess this back by a bit, because we'll actually want our window mullions to pop out a bit, and we actually want the base to be a bit recessed. Very last thing that I'm noticing here is that there's also this kind of column that's on the corner here that also has some very similar kind of datums that are on it that follow the same pacing as the one on the left. So we'll actually want to leave a space for that as well. So first thing, we want this to recess not too much, maybe 3 inches. And what we also want is for our column here, we'll just move this face. What we want is for this column to maybe have, let's say, a foot of room. That's just an approximation. Remove that. Okay. What we can do is to actually take these lines from here. Let's group them. Let's create a duplicate and let's bring them to this side. From there, what we can do is scale these like so. And that's just going to repeat our line detailing along this kind of thin column on the side here. So one thing that's really easy with this building is that the mullions sort of follow the spacing of the lines or the datums, and we also know that the top 3 floors are repeated, and it looks like it's kind of subdivided into 6 components that are all even. So what we'll do with that, if we kind of know that the floor will start from here, this line right here, again, we'll move it in by 3 inches just to reach that setback. And we can just like duplicate it up by 10 feet, like so. That looks okay. And one thing we'll want to be careful of is that we can't simply divide this into 6 and then make our mullions from there, because if we create our mullions using the center of these points, once they reach the edge, these mullions will actually be halved, and part of it will actually go into the wall on either side. So we'll actually want to account for that. What we want to do is to actually shorten this line from each side by half the distance of the width of our mullion. So in that case, bring it in by 1.5 inches, and same on this side. And what that's going to allow us to do is to account for our mullion here, which we have set as being 3 inches wide. That's probably unrealistic. That looks okay in this case, but anything that's kind of thinner than 3 inches might not look very good once you make 2D. It just might look far too dense. But from here, what we can do is divide this into 6 segments, and then we'll take our, we'll make a box, bring it from its center. Let's just snap it to there for the time being. And let's bring it up to that upper datum. Okay. So it looks like these sort of like cross beams do kind of cut off the vertical mullions. So I think it's okay if we have it kind of breaking the rhythm of it. Right, that looks all right. We'll just shorten that a bit. And from here, what we can do is array this over. And again, this is where our spacing mattered a lot. So you can see that it fits perfectly to this edge after we arrayed it. Let's also group these mullions. And what we'll actually want to do is to bring them back just a tad, maybe just 2 inches. From here, we'll also want to create that top portion. And since it's uniform, we'll also make it 3 inches. And same deal over here. Three inches, and we'll also want to shorten these as well so they're not intersecting. That looks okay. And this is, oh yeah, there's still a few more subdivisions left to do. So it seems like this line that crosses right here might kind of be at the, let's say, 45% point, and then there's kind of these like operable portions that rest on top of the solid portion. So what we'll want to do to achieve that is first set our line spacing. So actually what I'll do is just take this edge. Since this entire thing is 10 feet in height, let's say we bring it up by 0.45 multiplied by 10 feet. Oh, seems like that didn't work. Let's try that again. Maybe we'll bring it by 4.5 feet. Seems maybe a bit too tall, so maybe we'll actually bring it down by 6 inches. And from there, it seems like it was like a thinner mullion. So we'll just make it 2 inches. That looks all right. And what we'll actually want to do is to separate this out. So subtracting Boolean differencing with these thicker parts. All right. And then from there, you'll notice that the frames sort of have one portion that's kind of set back and then one that's set forward. Now, usually that's a detail that you'll want to consider, but for the sake of kind of modeling these buildings and just getting the idea across, I don't think it's too important. The basic idea is just that you want the windows to kind of read with the appropriate kind of subdivisions in mind. So what we'll actually, oh, sorry about that. What we'll do is actually just raise that, I believe is a total of 18 inches. And then we'll also want to create that middle line, which from there will create another box. And let's set it at 2 inches across. Okay. And subtract using the massing, and that's going to give us our kind of middle portion. So if we then take this and array it across, that's going to give us, oh, maybe not quite right. We'll just draw a new line, goes to there, and we'll array using that line. And maybe it needs to be 8. No, maybe 6. Oh, that's not right. Okay, we'll actually make a line from midpoint to midpoint. And hopefully with this, we can get a good, accurate array happening. Ah, I see the issue. So the pacing of this is actually quite different since it occurs in the middle of these windows. It works slightly differently in terms of how it's being arrayed. So what we actually want to do is to double what we actually have. So if we did let's see. It's not quite right. Instead of figuring it out mathematically, we can also just do it manually. So if we copy it, we can also copy it midpoint to midpoint. Probably a lot quicker than figuring out the math for it. Okay, that looks good. So we'll just select all of that, deselect all of that, and let's just group it together. Let's just make sure that it makes 2D properly. We did a lot of kind of Boolean work, and we're not sure if anything is like kind of intersecting. So it seems pretty okay. I think these are just our polylines that we have. But that looks good. So from here, we can isolate this, select our curves, delete them, show the rest of the building. And then we just repeat this, 10 feet, 10 feet. And maybe if we kind of took just, if we just took our mullions that are going vertically and snap them in place here, then we can kind of complete that detail at the top there. So we'll just scale them like so, and take this top bit, and I think maybe it goes up by 3 feet. And we can just cap all of these with that. Let's isolate that and also ungroup it so that we can delete those. Okay. Lastly, we'll just move this top face down a bit. And from there, we have most of the building done. That just leaves that kind of ground floor window, and it seems like it uses the same type of mullion for the most part. And do notice that this building is kind of on a slope. If topography is not a major component of your site, I would advise you to keep everything planar or flat. That's just going to make it a lot easier in terms of creating details through your buildings, getting things to line up. And in general, if you have topography that's kind of intersecting your building, it might actually make the communication of whatever you might be analyzing a lot more difficult. It might muddy up a lot of details, and it might also draw focus away from what you really want to look at. So just finishing up the rest of this building, let's just take a few of these mullions, just take them down. Okay. Seems like it's divided up like so. So maybe we'll move this over by, let's say, 2 feet. Move this one over by 2 feet, maybe 1 foot. And we also have those ones that go across. So maybe we'll lower this by 3 feet, raise it up by 6 inches again, lower it by 5 feet. And I think after we subtract this, do a Boolean difference, then I think that gets the idea across. Then what we can do from here is just delete these ones down below. Yeah. So that is sort of the front facade of this building. Of course, we still have the kind of roof detail and the parapet to complete. So from here, what we can do is actually make a rectangle. Remember, we have that kind of setback. What we want to do is kind of reclaim that original bounding box that we had. And using this, we'll do an offset of, let's say, 8 inches. We'll take the inner line and we'll extrude it down by, let's say 12 inches perhaps. And then from our massing, we can subtract this out, delete it, and that's our parapet done. And one thing to notice at the top is that there's actually this kind of lip that comes out. You can see it right there. It's this kind of like metal detail, just part of the construction of the building. And what we can do is take these sort of bounding lines and loft them together to get our surface. And actually, before we do that, let's actually offset this by, let's say, 2 inches. No. Offset by 2 inches, and the inner one. And let's actually extrude these down. And this time we actually want to not make it a solid, just a surface. Extrude it down by 3 inches. Same thing for the inner one. That's going to create our sort of lip. And then using the top line, what we'll want to do is loft it together. And that's just going to close it up. And from there, we can join this together. And that's going to create our sort of lip at the top. And it might be beneficial to actually raise this by 1 inch, just so it's not overlapping things. And let's say we make 2D. What we'll see is that this lip actually makes quite a big difference. And even these lines, these seam lines that kind of go at 45 around the corners are very accurate in terms of how these how this sheet metal is put together. And yeah, that looks quite good. All right, next up, moving on to the roof detail. We'll see that we have a few more boilers, we have some pipes running across, and we also have this main sort of like room, presumably for the emergency stair. So what we can actually do is take our boiler unit that we modeled for the office tower, and of course it's far too big, the fans are too big, but we can just scale this by half. And what we can do is maybe take half of it. Let's see how many fans we have. So it's just 1 each. So in that case, what we can do is actually create a box and maybe just isolate 1 fan by simply differencing all of that stuff out. So if we actually explode this block and then take a Boolean difference, seems like that didn't work. Let's just make this a tad bigger. A lot of times if things are kind of overlapping directly in terms of like their faces being on each other, then it makes it a bit difficult to Boolean difference, but let's try this again. It's really not liking that face, so let's just X out a bit. It's really not liking it. Okay. Let's just do it with that. That worked. And let's just take this little unit off. From here, what we can do is simply extend this a bit. And it's starting to look very close to what we want. So if we just adjust these faces a bit, take that bottom face up. All right, this is our kind of basic unit. And for the most part, if you kind of have one of these mechanical units modeled out in another building, generally all the elements can be reused, as it's basically a prosaic, and they all look very similar for the most part. Also be useful to remove points. Just a bit distracting. Okay. From there, we can just model out our little room. I'm not being too precise with this. Actually, this looks quite big. And it's also horizontal. Just gonna snap this back to the roof. That looks all right. And this thing also has its own little parapet. So again, you can take the border, you can offset it. Oh. Offset it inwards, and then just subtract an extrusion from here. And we'll also want to make this a solid extrusion. Okay, you can add a door to this if you want. And in terms of how one might do piping, you can use the pipe command in Rhino. So if we just draw the kind of base curves for our pipes, and do just like so. And if we just kind of have these grouped as one, and maybe we want to create a bit of complexity, let's just like make duplicates of them, offset them a bit, drag this out a bit, maybe scale it. And really it's just about the effect that it creates, not necessarily about, imitating directly what is in the reference, but just getting the idea across. So with this, what we can do is hit pipe. Let's make them all 1 inch in radius, and let's also give them some round caps. So with that, we kind of have our pipes here. And a few other details I may want to add is just maybe a few kind of mechanical boxes that might intersect it. I'm not too sure, but some of these details could be helpful. You can also scale them down. And really it's just kind of bashing together a lot of geometry and to get the idea of complexity across. And once you're kind of done with that, then good thing to do, of course, would be kind of isolate them and then just Boolean them together. Boolean union, just so that we don't have things that are intersecting. You can see that if we make 2D with this, that our lines are very clean and there's no issues. There's nothing to clean up afterwards, and that's very important. So from there, let's say we're making an isometric drawing and we're kind of seeing the roof of this building. Maybe one issue. We're actually going to want to maybe raise this just by a tad. Or we can alternatively subtract it. Subtract with the roof because that was an intersecting element. But if we make 2D, you'll see that everything is quite clean for the most part. Not a lot of lines need to be trimmed. In fact, I don't see any lines that really need to be trimmed. And really it's about the effective use of kind of simple shapes, lines and edges that from Make 2D will kind of result in the right kind of hierarchy and density detail that will look good at this scale. And you can even see that this kind of datum for the lip on the parapet could probably do without this line. And you see it looks a lot better. So really it's about controlling a lot of density with these buildings. All right, and that's that for the parapet building. Next up, we'll just want to look at a few sidewalk details. So maybe we'll want to look at some of these traffic cones. Just like this. We might want to look at a few of these traffic cones. Maybe tackle a few of these street signs, and just general street details that might be helpful for populating some streets. So the first thing with like traffic cones, one thing that's really easy to do is to make a polygon, and in this case this is an octagon, so it has 8 sides. That's good. And you can always, rotate this to make it square if you want, like that. And let's just get this cone in. And this is where it's really going to depend on the level of detail that you want to achieve. You can see that these cones are actually quite detailed. They have a lot of these kind of ridges. They have this hole through them with a bunch of chamfers. And if all of this was modeled and you made 2D, all of the edges would be registered, and it would look like kind of this dense black stick in your drawing, and it's not going to look quite good. So I'll show you a few kind of levels of detail that you can model this at. The first is kind of like, let's say, a very basic cone or basic cylinder. So what you can do is take, you can scale these lips out like so, and then what you can do is maybe just make your base cylinder and then have these lips around them like that. And then for the very top, what you might have is a little cone. So if you just reduce that scale, that maybe another one that might be a bit thinner. And if you lofted these together, then you get that basic shape. I think the circles at the top could probably be a bit bigger. So if you loft these together and cap the shape, that's kind of like your basic traffic cone. And let's say we sort of get the base in place. You can align this, snap it in place. I'm just gonna align it very roughly. And let's just raise this by 1 inch. Remove the bottom portion, difference it out. And let's just say we group this together. You don't even need to join it. Or actually, probably better to Boolean union. And let's see how this looks. So you'll notice that these rings, since they're kind of like a very thin datum, the lines are very close to one another, and that's going to result in a very kind of thick and dark line. And it's not ideal when you're very zoomed out, so that's just something to be cognizant of. when you're kind of producing these things. Alternatively, what you can do is also just make a simple cone. So what I'll do is I'll actually just remove this top portion entirely. I'll just subtract it out. And from here, what I'll actually do is I'll create these kind of instances of separate cylinders. And then from here, I'll just run one throughout and then subtract these from there. So you'll see that we have these kind of like joints of cylinders at different rhythms. And for the very top, what I'll do is just a very simple cone. Again, using a loft and capping it. And if we make 2D for this, what we'll see is that it's a lot simpler, but arguably it gets the idea across a lot better. There's not a lot of kind of overly thick lines resulting from like, you know, super minute details. And in general, this might be more effective if your drawing is very zoomed out from a long distance. A few other things that you might also want to look at are things like fire hydrants, and these are also very simple. You might look at them and think, oh, there's a lot of curves, there's a lot of tapers, it's very complex, but for the sake of a kind of street scale drawing, it can actually be quite simple. So ignoring scale, assuming that you can kind of dimension this out, you can simply use cylinders to create a fire hydrant. So let's say that we have our base here, and we kind of have our main fire hydrant. That's right here. What we can also do is just create the two ends like that. And also scale that down. We can take these faces, we can also make them bigger, and that's going to create our kind of end caps. And maybe that's a bit big. Again, mirror this to the other side. And for the very top, you might actually use something like a sphere. So first, what we'll do is just create a top lip, like so. And I'm just going to check the center snap, and then what I'm going to do is take a sphere and maybe chuck it on like that and just subtract it out, keeping the top portion only. And that's kind of like a very simple way to create a very quick fire hydrant, and there might even be a few more details that you want to add. So if we take this border again, let's say we have these tiny little, I guess they're bolts that might stick out. So we can make this even smaller. Might be sticking out too far. Something like this. And with this, we might want to just might want to just mirror it according to this. So just grab this line. And mirror it like so. And from this, we can get something that, while very simple and uses a lot of simple shapes, looks very close to a fire hydrant. And if we kind of make 2D, I think we still have some intersecting shapes. So what we'll do is actually just Boolean this together. Okay, let's make 2D. Where do we go? Right here. Yeah, so ignoring our polyline that we left on there, I think it gets the idea across. You might want to have kind of a top portion to it. Maybe it doesn't end in kind of like a dome at the top, but when you're looking at it from a distance, it gets the idea across without you having to spend a whole lot of time just working on something as simple and maybe as irrelevant as a fire hydrant. The idea is to get the most bang for your buck in terms of the amount of time that you're putting into modeling and the resulting effect that you might get from it. So that concludes the portion for modeling in terms of modeling entire office buildings, going down to more mid-rise storefronts and parapet buildings, and then all the way down to the simplest street details and elements. And the general idea is that in all of these, you can abstract a lot of details, you can repeat a lot of details, and you can save a lot of time by using prosaic elements such as these boiler units back to your parapets and vice versa. And in the next portion, I'll just be talking about how to get an isometric export from Rhino to Illustrator, and then also how to set up a view and a clipping plane for a section perspective. Thanks again for following along with this tutorial. I hope that it was helpful, and I look forward to seeing all of your work in ARC200. Thanks so much.